Alright, in this video I'll be doing problems 46 through 50, basically the last 5 problems of the final review for college algebra. So here if we're going to be using Gaussian elimination with back substitution, which is what we've been doing in class. And in doing that, what we're trying to do is get this matrix, this form of a matrix, where we have, let me just finish this, ones on the main diagonal, zeros below the ones, and numbers elsewhere. And then we would use back substitution by changing this back into equation form and using back substitution. And so let's go ahead and get started. So we would start with the matrix 3, 2, 6, 2, negative 3, negative 9. And I need to get a 1 in the upper left-hand corner. That's where we always start, right here. And so it's not as obvious as some of the other ones we've done. The easiest way to get a 1 there is just multiply the second equation by negative 1. And if you add negative 2 to 3, you'll get the 1 you need. So we're doing negative 1 times row 2. We're going to add that to row 1, and that'll become the new row 1. And so it's a little different than some of the others we've done, but that would be the easiest way. So row 2 doesn't change. Let's go ahead and put that in. And then if I multiply times negative 1 here, each of these signs change. So we'll do negative 2 plus 3, which is 1. 3 and 2, which is 5. It'll be positive 9 and 6, which is 15. And so the new row 1 is 1, 5, 15. So now that we have this 1 that we needed, we use it to get the 0 below. So notice negative 2 times row 1 would give me a negative 2 here, so that when I add to this 2 here, I'd get 0. So we're going to do negative 2 times row 1 and add that to row 2, and that'll become the new row 2. And so let's go ahead and do that. I'm going to rewrite row 1 since that's not changing. So negative 2 times row 1, that's negative 2. And negative 2 times 5 is negative 10. And negative 2 times 15 is negative 30. So I've already multiplied this first row by negative 2. Let's add it to the second row. Negative 2 and 2 is 0. Negative 10 and negative 3 is negative 13. Negative 30 and negative 9 is negative 39. And so that's the result of what we did. Notice this last row, if I want to get a 1, well, let me just put it this way. We've already got the 1 in the upper left-hand corner and the 0 below now. So we move down the main diagonal, and now I need a 1 here. The easiest way to get that 1 is to just divide by negative 13, and it just happens this number is also divisible by negative 13. So that works out nice. Now we'll write it as multiplication by the reciprocal. Negative 1/13 times row 2 is going to become the new row 2. But really all we're doing is dividing by negative 13. So 0 divided negative 13 is still 0. Negative 13 divided by negative 13 is 1. And negative 39 divided negative 13 is 3. And so now we have that desired form that we were looking for. And so let's change this to equation form. And we'll use back substitution to finish solving the problem. So you can see that y is 3. Notice we had 1x plus 5y is 15. And 0x plus 1y is 3. So y is 3. We'll plug 3 in for y here. We have x plus 5 times 3 equals 15, or x plus 15 equals 15. And we'll get x equals 0. And so our point is going to be 0, 3. That's our solution. And that's it. Now, if you had put this original equation or a matrix into your calculator and you did the reduced row echelon form like what we did in class, you would end up with this matrix here. where you can see x is 0 and y is 3. So I would remind you on the final that you can always check any answers with matrices or systems using your calculator, even if you're asked to do it another way. You can always check it on the calculator. So number 47 is a good example. So again, we're going to use Gaussian elimination with back substitution. Again, the other technique is where you basically put it in this other form, which we didn't actually do in class this semester. So let's go ahead and write this as a matrix. So I'll do that real quick. I would remind you to just be careful. I usually go across the rows when I put in my numbers, and then I check them the other direction. So 1, 2, 5. Second column is -1, -3, 1. And then third is 1, 4, -2. And the last column, -4, -15, 12. And so we got the 1 that we wanted here. We didn't have to do anything for that, but we're going to use that 1 now to get zeros below. So we'll have to multiply the first row by -2 and add that to row 2 to get the new row 2. And we'll have to do -5 times row 1 and add that to row 3, and that'll be the new row 3. So hopefully you've already tried this, but if you want, you could be doing it step by step, and I would encourage you to do those row operations and then turn the video back on. So let's see how you did. So we'll multiply by -2 in the first row. -2 times 1 is -2 plus 2 is 0. -2 times -1 is 2, and a -3 is -1. -2 times 1 is -2, added to 4 is 2. -2 times -4 is 8, added to row 2 is -7. So we get 0, -1, 2, -7. Now we need to multiply the first row by -5 and add that to the third row. So -5 times 1 excuse me, is -5. Plus 5 we get 0. -5 times -1 is 5, and 1 makes 6. -5 times 1 is -5, and -2 make -7. -5 times -4 is 20. And 12 is 32. And so that's your new matrix. Notice we have the 1 in the upper left-hand corner, then the 2 zeros below. Now we'll go down the main diagonal. Excuse me. And we need to get a 1 here. Now that's going to be pretty easy. We could just multiply this whole row by -1. So let's do -1 times row 2, and that'll be the new row 2. So let me go ahead and write in the first and the third rows. They don't change. And we really just need to switch the signs. Of course, -0 is still 0. We'll get a 1, -2, and 7. All right, so we've got our 1 here. Now we want to use it to get a 0 here. All right, so we need to multiply -6 times row 2, add that to row 3, and that'll be the new row 3. All right, so let's go ahead and rewrite the first 2 rows. Those don't change. All right, on the third, so when I multiply -6 times 0, I get 0. Adding that to 0, we get 0 here. -6 times 1 is -6. Added to 6, we get the 0 we were looking for. -6 times -2 is 12, and a -7 is 5. And -6 times 7 is -42. Added to 32 is -10. So we're pretty much done except for this last row. Now we have the 1 and the 0 here, so we'll move down the diagonal, and I need a 1 here. I can divide by 5, and this just happens to be divisible by 5 too, this negative 10, so that works nice. So we'll do 1/5 times row 3, and that's the new row 3. So I'm going to rewrite the first two rows. And then you divide 0 by 5, you get 0. Same thing here. 5 divided 5 is 1, and negative 10 divided by 5 is 2. And I'm sorry, I need to move this down a little bit. So 0, 0, 1, and 2 are what we get there. And so now we've got the desired form. Let's go ahead and write our equation up here, our system. It'll be x minus y plus z is negative 4. Y minus 2z is 7. And z equals 2. So we can replace this z with 2. We get y minus 2 times 2 is 7, or y minus 4 is 7. Something is not right. Hold on a second. I think I made a mistake. Oh, I see what I did. We divided negative 10 by 5. That should be negative 2. I knew something was wrong because my answer wasn't coming out right. This is a negative 2. And so this becomes plus 4, and so y is 3. So far, we know z is 2, y is 3. Let's use this first equation to find x. So we can plug in 3 for y, and whoops, this is negative 2 here, and negative 2 for z. Of course, negative 3 plus a negative 2, that's negative 5, or x minus 5 is negative 4. And we'll add 5 to both sides, and we get 1. And so 1, 3, 2 is your solution. Again, you should be able to take this matrix and do the RREF on your calculator, and you'll get this matrix here, which tells you x is 1, y is 3, and z is 2. So again, you can easily check your answers. If you have issues with your work, you're not getting the right answer, your answer should check, and it does here. All right, so that's 47. Let's move on to 48. So in this case, we've talked about how to do row operations to solve a system. And the last case was generally what happens. You get an ordered triple, and that's your solution. In number 48, it says, when solving a system using Gaussian elimination, you end up with the given matrix. What is the solution to the system? Well, here, notice that if you change this to equation form, you have x minus 3y equals 9, and 0 equals 7. 0x plus 0y equals 7. So this is a false statement, and so we know we have no solution. This would be the case where these two lines are parallel, and that's why there is no solution. Let's look at the other case in part B. So let's say you're solving 3 equations and 3 variables, and you end up at this matrix. What does that tell you when you have a row of zeros? Well, it tells us that there's infinitely many solutions. The reason why all of our equation fell out was because it was equal or equivalent to another equation. So 2 equations were essentially the same. And so in that case, you have infinitely many solutions. But that's really kind of lame because it doesn't tell me anything other than there's infinitely many. It doesn't actually even give me any solutions. So you'll be asked to write the form of your solutions. So to do that, you'd want to write these equations out. You have 1x plus 2y minus 3z is 4, and x plus 4y equals 5. And so, excuse me, I'm sorry, this should be x plus 4z. So notice you could solve for x quite easily here in terms of z. So putting all of our answers in terms of z, or using a parameter of z, makes sense. So we're going to call z, z. And if we solve for x, we get x equals 5 minus 4z. And now I just need to write x in terms of z. Well, z I don't need to replace because we're using z for z. But y we said was 5 minus 4z. So it'll be x plus 2 times 5 minus 4z minus 3z equals 4. So it's this equation replacing y with 5 minus 4z, and z, of course, just stays z. And so now I can solve for x in terms of z. This will be x plus 10 minus 8z minus 3z is 4, or x plus 10 minus 11z equals 4. I want x by itself, so I'll subtract 10 on both sides, and I'll add 11z. So we end up with x equals, we'll just put the 11z first and then the minus 10. And so 11z minus 10, that's my x part. Oh, let's see, where did I? Let me double check something. I think I made a mistake again. Let's see, 10. Oh, 4 minus 10. That should be minus 6. I knew something was wrong because my answer wasn't matching. All right, let's move on to number 49 and 50, where now the main thing is that you can translate these into systems. Now here it does say use substitution or elimination to solve. So for both of these problems, once we get them, the system determined, you should be able to use the elimination method, like for number 50, or on 49 you could use elimination or substitution. But our focus, and it will be the same on the final, is to use your calculator. I think on the first one, because it's pretty simple, I'll just use elimination. But on the second one, we'll definitely use the calculator. Although it's not too hard to do it by elimination or substitution. Sorry, I have a scratchy throat here. So there were 149 people at a summer camp, including students and camp counselors. If there were 79 more students than camp counselors, how many students and camp counselors attended the summer camp? All right. So x equals the number of students. And we'll say y equals the number of camp counselors. So we have 149 people. It's all students and camp counselors. So one of our equations is definitely x plus y is 149. Now next it tells us that there's 79 more students than camp counselors. So basically the number of students, which is x, is or equals 79 more than the number of camp counselors. Well, the number of camp counselors is y, so it's 79 more than that. Now, I want to have all I could use the substitution method to solve this, so that would certainly be a good idea. I'm also going to put it in this other form. So it would be x plus y equals 149 and x minus y equals 79. For some people, this equation makes a little more sense, the second equation. Notice if you have more students than camp counselors by 79, if you subtract the two numbers, you should get 79, taking the larger number minus the smaller number of students minus number of camp counselors. So either of these systems are perfectly fine. I'm going to go ahead and use elimination method here because it works out quite nice. You get 2x is equal to 228. And if you solve for x there, you get 114. Now we know that x plus y is 149. And so 114 plus y is 149. We're going to get 35 when we subtract 114 on both sides. So we've got x is 114 and y is 35. That tells me there's 114 students and 35 counselors. Notice these numbers do add up to 149. And if you subtract them, you will see that there are 79 more students than camp counselors. All right, so that's the first one. Excuse me. Now, if you had made a matrix for this system, it would have been 1, 1, 149, and 1, negative 1, 79. And then we would do the RREF, and you would get 1, 0, 114. And 0, 1, 35. Again, that tells you x is 114 and y is 35. All right, let's move on to 50. This is going to be it. So you have 226 points on 3 tests, the student does. The sum of the scores on the first and second test exceeds the score on the third test by 62. And the first score exceeds the second by 6. Find the 3 scores. So let's call x the first score, y the second score, and z the third. In fact, I would encourage you to see if you can write the system if you haven't already done this. This is the kind of thing you're going to have to do on the test. The other place I would ask you to if you see similar problems on the assignments we've done, like this one here, I would encourage you to look back at those. The problem you'll see on the final will be very similar to this. All right, so I'm assuming you've already given it a shot. You would say x plus y plus z is 226 points. That's your total number of points from 3 tests. It says the sum of the scores on the first and second tests. Well, that would be x plus y exceeds, or you might use the words is more than, the score on the third test by 62. So is more than, or exceeds, we would say equals, I want 62 more than the third test score. So that would be z plus 62. So again, read it again. The sum of the scores on the first and second test exceeds or is more than the third test by 62. So 62 more than the third test. So hopefully you can read that and make sense out of what we wrote here. It's really important that you understand the equations. All right, and then it says the first score exceeds the second by 6. So the first score is more than the second by 6. So the second score is y. More than that by 6, that would be y plus 6. So again, the first score, x, exceeds or is more than the second, so is means equals, more than the second by 6. You would write the second test score, which is y, plus 6. All right, so we want to change this so that all our variables are on the left. So it'll be x plus y plus z is 226. X plus y minus z is 62. And x plus y, and there's no z, equals 6. And so your matrix is 1, 1, 1, 226, 1, 1, negative 1, 62, and 1, 1, 0, 6. You'll do R, R, E, F. And when you put that in your calculator, you should get 1, 1, 1. Oh, wait, no, that's wrong. 1, 0, 0, 75, 0, 1, 0, 69, and 0, 0, 1, 82. That tells us that you got a 75, then a 69, and then an 82 on your 3 tests. Whoops, I'm sorry, I got off the grid a little bit. Just real quick, I'll show you in the calculator if you weren't here when we did that, or maybe you forgot. So I want to put this matrix here into the calculator. So we go into second, and then see x to the negative 1 matrix. So second matrix, notice it's on matrix A. We want to edit this matrix. It's a 3 by 4 matrix, 3 rows by 4 columns. So we would 3, enter, 4, enter, and then put in the numbers in each time you hit enter. So 1, enter, 1, enter, and I'll just keep going. Remember to put negative numbers in using the negative sign at the very bottom. So it's nice on the CE, you can see the numbers and make sure everything is incorrect or entered correctly. Now I'm going to do second quit. If you don't have the C and you can't see the whole thing, you could also do second matrix, and notice it's on matrix A. Just hit enter twice and you can verify that you put it in right. And so now we want to do some math with that matrix. We want it in reduced row echelon form, RREF, and so we'll do second matrix. We'll go to the math button and arrow down until we get to RREF. Now we need to put the matrix in there, so second matrix again. Notice it's already on option A, so hit enter and enter again, and there is your answer. What did I do? Oh, I see what, boy, I don't know what I did. Let me go back to my matrix. All right, let me go back to the front page. So second matrix, math, RREF, second matrix A, oh, that's strange. Let's see what is going on here. I'm doing something wrong. I've never had this happen. I may have to do another video just for this last problem. I'm not sure what I'm doing wrong here. Let's see, 111, 226. Oh, I see what's wrong. Let me fix this here. There's actually, oh no, that's wrong. Oh, I see. Oh, let's see, maybe I don't see. Let me go back to second matrix, edit. Oh, I see what's wrong. I should have had a minus y here. So this is a -1 here. So notice one button entered in wrong really messed me up here. So let's do second matrix, edit, and let's make that a -1. Let's do second quit, second matrix. We're going to do math, so we want to, whoops, boy, I'm going too fast now. Second matrix, we want to do RREF. Second matrix to put matrix A in there. So I guess I showed you one number messes it all up. Let's see if we get it right this time. There we go. There's our 75, 69, and 82. All right. Well, if you have any questions, let me know. I'm sorry I got off the screen a little bit there too, but if you have any problems, let me know. That's going to be it.